So on the review, number 17. All right. So for this problem, the first thing I notice is that whole integrand. I can't take the integral of this whole thing just the way it is because I don't know any function that when I take its derivative gives me exactly v squared cosine v cubed. But what I do notice is I have a composite function, and the inner part of the composite function, I have its derivative, or at least part of it, being multiplied by the function. So for me, this tells me u substitution. So I'm going to let u equal that inside part, v cubed. And then du would equal 3v squared. And I'm going to have to divide by 3 because I don't have that 3 in there. Sorry, that should be a 3v squared dv. The other thing when I have u substitution, I really like to change and get my limits in terms of u. Interesting thing happens when I do that. If I plug 0 in for v, I get 0. If I plug 1 in for v, I get 1. So my limits actually are not going to change. I find it interesting. I'm going to have the 1/3 integral from 0 to 1 cosine of u du. And the integral of cosine is sine, evaluated from 0 to 1. And then I can plug in and simplify from there. The big thing here, make sure you're in radian mode if you're going to use a calculator, because all angles are measured in radians. All right. Make sense?
Yeah.
Okay. And then 18. So again, for this one, I have a composite function. So my first thought would be u substitution. And I don't have that 3 pi outside of the sine function, so I would divide by 1 over 3 pi. Again, my limits, my lower limit, if I take 0 and plug it in for t, I get 0. And if I plug 1 in for t, I get 3 pi. So 1 over 3 pi times the integral from 0 to 3 pi of sine u du. Integral of sine is negative cosine. And we'll evaluate that from 0 to 3 pi. So when I plug in 3 pi, I get the opposite cosine 3 pi minus the opposite cosine at 0. So that's going to be plus a positive. Cosine at 3 pi is negative 1. I'm taking the opposite of that. Cosine at 0 is positive 1. And so that's how that one ends up. All right.
How do you know when, like, the U substitution or like the UV one?
All right. So the big thing, and I'm going to go back to that first example. So if there's multiplication, so we have a function times a function, I'll use U substitution if this function is the derivative of this function. So v squared is definitely part of the derivative of v cubed. The only thing missing is that constant 3. So that's going to be U substitution. I would use the other one if the two things that were being multiplied were not derivatives of each other. So for instance, if I had the integral of, I don't know, x squared e to the x. X squared is not the derivative of the power here of x. So like I wouldn't use substitution here. So in this case, I would have to use integration by parts, the u, dv, and fun things like that.
Can we also go over 29?
Oh my goodness. Yes.
I'm sorry. Thank you.
Not a problem. All right. T squared plus 6t plus 8. All right. So we have a rational function, and the derivative of the denominator isn't anywhere to be found in the function. So I can't use substitution. I really don't have two functions here. So elimination, integration by parts probably won't work. So Then what I need to look at is my fraction. And this is one that I would use that idea of partial fractions with. So if I factor my denominator, I know that that fraction can be written as something over t plus 2 plus something over t plus 4. And so if I multiply by t plus 2, t plus 4 on both sides, I will get a times t plus 4 plus b times t plus 2. Distribute my a and my b. So my numerator of my fraction was just 1. It didn't have any t's. So 0 has to be equal to the terms with t's in them, the coefficients of the terms with t's. And my whole number has to be equal to the terms that don't have a t. And then you have a choice. You can solve this by elimination. You could solve it using substitution, kind of up to you. This one actually works out pretty well for substitution. I know that A would have to be the opposite of B. So if I put in a negative B here, B would be negative 1/2. Because A is the opposite of B, A would be a positive 1/2. So all of that work gets me to write this as the integral of dt over t squared plus 6t plus 8 is going to be the integral, and I think I did it x plus 2. Yep, okay. So the 1/2 for A I'm going to write out front. And then the negative 1/2 for the B I'll write out out front as well. Excuse me. So I have 1/2. The integral of 1 over t plus 2 is the ln of the absolute value of t plus 2 minus 1/2 times the ln absolute value t plus 4. I don't have any limits, so I need to remember that constant. Very important on the AP exam. Remember that constant. And then there are a bunch of different things we could do to simplify this. I'm pretty sure if you looked at the answer key, that might be in there as part of their solution, but they didn't end there. They probably brought the coefficients inside. And then they probably rewrote it because if we have logarithms that are being subtracted, we can write that as division. So you may have seen it like that. They may actually have, and I don't remember in the answer key if they took it one step further and just said this is t plus 2 over t plus 4 all to the 1/2. They might have. So any of these are all equivalent and are all acceptable answers. All right. Any other questions?
Could we also do 40?
40?
They do.
I don't know if I know how to do 40. Oh, I know how to do 40. Never mind.
You see, I don't.
All right. We want to find G prime. We want to find the derivative. And the big key here is to remember that if g of x is some integral oh boy, I need some different letters. H of t dt. The fundamental theorem of calculus says that G prime is going to be H, but instead of T, I'm going to plug in f of x. And then I'm going to multiply by the derivative of f of x. So in this case, I plug in sine x everywhere I see a t. And then I multiply by the derivative of sine x. And you could definitely leave it like that. Again, the answer key probably changed 1 minus sine squared. That's equivalent to cosine squared. So, and then we have a cosine here. So it might be written as this way as well. Again, they are equivalent. The only time you would need to possibly rewrite it would be it might be that way on like the multiple choice version of a multiple choice question on the AP exam. All right. Anything else? All right, just a couple of things and then we can